let me just start with welcoming all of you to, I think this is probably the first ever fully virtual Blue Heron Bowl. We certainly appreciate all of you participating. And also, I'll just start by also appreciate your patience as we move through this, since this is also the first time we have organized and run a totally virtual Blue Heron Bowl. So thank you in advance. How about that? Hopefully next year we will go back to whatever normal might be and see you all participating again in a fully functional Blue Heron Bowl face-to-face. And so I am very excited to have the opportunity to introduce a very good friend, a great colleague, an incredible scientist, Dr. Lisa Clow. I've known Lisa for better than 20 years now, I think, Lisa. Lisa, I won't go through all of her career, but she does have an oceanography degree from Stony Brook. And shortly, if not right after getting her oceanography degree, her PhD from Stony Brook, she came to East Carolina University, ECU, and sort of moved up the ranks through ECU through almost, I think, 20 years at ECU, taking on additional leadership roles at ECU until she had an opportunity to spend some time at NSF as a rotator. So somebody that really was focused on the science, the polar science at the National Science Foundation, right? So the premier institution that really leads science and funds science for the US. It was in 2015 that Lisa, Dr. Clow, took on the head of ocean sciences, the division of ocean sciences for the National Science Foundation. And so she's continued to move up the ranks and is at one of the highest ranks now within the National Science Foundation, focused on some of these critical science questions, these challenges that we face across our largest scape, which is the ocean, right? So, I mean, it does represent 70+% of the coverage of our globe. And so it's a pretty critical area. And thank you to Lisa for leading that charge and thinking about the science and dealing with these challenging questions. And I have to give it to Dr. Clow, is the one thing that I have always recognized is that regardless of how challenging these questions are, she has always been so optimistic and has a great picture of what the future can and hopefully will be. And I've always appreciated that of Dr. Clow. So I'm excited that you have the opportunity to hear from Dr. Clow, particularly given the focus here of the polls. Dr. Clow does recognize that she is geographically bipolar, so she does recognize that. She has been both to the Arctic and the Antarctic. And with that, I'll just hand it directly over to Dr. Lisa Clow.
Thank you so much, Reed. And thank you guys all for spending some of your very valuable Friday night time with me. I'm really excited to tell you guys a couple stories tonight for the musicians in the group. I've taken to trying to set my talks up with a prelude to sort of set the tone. We'll hit a few punchlines and then we'll finish at the end with what I'm affectionately calling a coda. And let me go through the three stories I want to tell you. Is I'm going to do a bit of the setting with, unfortunately, the glass half empty and sort of the crises that we all have on our plate as challenges for the entire planet, quite frankly, right now. Then we'll go into the stories I want to tell you a bit more about my background, but really an emphasis on kind of how I got interested in climate and equity. I'm going to tell you an Antarctic story that's a little scary and quite frankly, probably the only time I really walked out of a science talk and was like, oh crap, we're in big trouble. But I'm going to then tell you an Arctic story that I think maybe has a solution or two. And then we will finish with just a few things, again, sort of other challenges, but also opportunities that are out there. So without further ado, let's go ahead and get this talk going. Oop, hold on, there we go. All right, state of the planet. What do we think? Well, well, so this is actually just a screen capture from the word crises and within the federal government. And I am a part of the federal government and within the executive branch. We got 4 crises that our new president has outlined for us. So what are they? Well, probably not surprisingly, COVID, first and foremost, there we go. Very much associated with COVID is our economic challenges. Obviously, normal went out the window about in the end of February, about this time a year ago. And so while we're making adjustments, there certainly are quite a few people that are hurting out there. Equity. All right, we very much recognize that we have a problem and different people within the United States because of the color of their skin, maybe their gender, maybe their sexual orientation, but you know, they have a different reality than others have. So at NSF with the National Science Board, we refer to the missing millions. So when we look across the STEM fields, science, technology, engineering, math, and sometimes we throw that extra M on for medicine, we really don't see that the population of the United States looks like the scientists, engineers, mathematicians that we have within the field at the moment. So we have to do better there. And sort of one that might immediately leap to the fore with your emphasis on polar for this particular Blue Heron Bowl, climate. So President Biden has very much put front and center that we are in a climate crisis. So things are changing dramatically. If humans change our behavior, they won't necessarily, the climate won't change as much, but we are locked in for a climate that is different than what we've had for the last several tens of thousands of years. So I would like to do a poll to give me just a little bit of insight into you guys. So Parker, if you can launch poll number 1. All right. Tell me a little bit about you guys, and everybody's welcome to answer, but solving one of the 4 crises, are you doing something about it already, or would you like to contribute to any of these 4 crises? And there we go. Look at that. We got a lot coming in on climate and equity. Awesome on the fact that we've got COVID and the economy in there as well. We got a lot of work to be done on all of these. So we are doing great. And we're up to most folks having voted. What do you think, Parker? We got close. You want to end the poll and show everybody the lock-in?
Sounds good. Give me 1 second. All right. End poll and sharing results.
Great. All right. So everybody have a look. 85% of you are very interested in the climate crisis. Got a close second on the COVID and the equity, and definitely some interest in the economic crisis as well. So let me actually move on to the next one and share a quote. And you guys probably know who this quote is from, but go ahead and put it in the chat if you know who this is from. This is all wrong. I shouldn't be up here. I should be back in school on the other side of the ocean. Yet you all come to us young people for hope. How dare you? Absolutely. It is Greta in her How Dare You speech to the UN in 2018 before COVID and everything else hit. And I absolutely want to thank all of you guys, because really you should, in fact, be just focusing on school and all these other things. but we need you. So I am sorry that we are in a world with a lot of hot messes, but I am indeed hopeful. I see all the enthusiasm and the call to move from knowledge to action. So I want to thank everybody on the call, and really just all my respect for all of you for what you're doing in these very challenging times. So let me give you a little bit of where I came from. Reed did a great job doing some great stories about me. And I am indeed geographically bipolar. So I have stood literally on the North Pole and literally on the South Pole. So in the sidebar there is what the poles look like in January. I didn't quite capture the February timeframe, but it's basically the limited ice extent down in the Antarctic, which is your globe there. And that is the ice. And then here's what the Arctic looks like, both in terms of ice on the Arctic Ocean, but then also the snow-covered region. And I grew up in Buffalo, so I am used to snow, not so much on the salty water side, but it really did set the stage for me in terms of loving science. And I went to a magnet school in Buffalo in the late 70s, early 80s. Rather than having busing, they actually created schools where everyone in the city of Buffalo could go to, and we strove for racial equity and parity in these different schools. And my school focused on sort of all aspects of sciences, and I really love that, and I really was quite interested in the sports teams as well. For my undergraduate, I went to Wesleyan University, not the one in Rocky Mount near you guys, but the one in Connecticut. And I actually thought I was a biology major from the get-go, and really enjoyed the biology quite a bit. But I started going, ooh, there's like this geology stuff and cool oceanography. So I wound up being a double major in earth and environmental sciences as well as biology. And I started kind of getting interested in social science as well, kind of recognizing that if we're going to do something, we kind of got to understand what humans are doing. So I dabbled a little bit in, okay, let me take an anthropology class or a sociology class. And Wesleyan very much prides itself on being diversity university. And there's a whole lot of women rights type activism there as well. So I was starting to get centered in kind of what's going on with climate, what's going on with equity, certainly at the undergrad stage. I did an undergrad thesis, and I was pretty burnt out. So I took a year off and hung out in Europe and tried to get myself exposed to some other cultures. And then I did a PhD at Stony Brook. And Stony Brook, your degree is in oceanography. So I was really interested in interactions across the sciences, and happened to be ready to sort of settle down, and met my husband at that point in grad school. And as Reed mentioned, pretty much right out of grad school, I didn't actually even officially have my PhD yet, headed to Stony Brook headed to ECU, East Carolina, for a postdoc, and really just loved ECU. Wound up spending about 20 years at ECU, and very much, ECU front and center has a public service commitment, and really wants to see knowledge to action. So looking at the applied science, and I also came to really appreciate, via some of my Arctic work, Indigenous knowledge. And so I think all of these things were sort of coming together. I went to NSF as a rotator, as Reed mentioned, and sort of became bipolar. So that was my first time in the Antarctic in 2009, but I had been going to the Arctic since about 1993. And came back to ECU, went back to NSF, and am now in my current position as a section head. I'm adding in the components of policy. I really work internationally. I sit on some G7 organizations, and I am doing science at sort of a different scale now, or I shouldn't say doing science. I am enabling science at a different scale now, where we really do have projects that encompass the entire planet. So let me change to two Arctic and Antarctic stories, since you guys are focused in on polar for the next day or so. So Antarctic, a continent for science and peace. It's pretty easy to set aside a continent for science and peace when 98% of it is covered by ice. So only 2% of Antarctica is actually ice-free. But it's pretty big. So this is actually an app that I love, where you can sort of, the 2D maps sizes get all distorted. So what you can do is actually move the areas that you want to compare to one another on top of one another. And in yellow, sort of down on bottom, I apologize if I have color blind folks. I didn't think about that when I made this slide. But you see the outline of the United States, and then in the day glow green is actually Antarctica. So Antarctica is bigger than the 48 contiguous United States. So it's a big place. Okay, I put Alaska on there. Alaska certainly is a big place as well, stretches from our northern border down to our southern border, and sort of from the Midwest over to the East Coast. And there's Greenland, just for comparison as well. We're not going to talk about Greenland tonight, but Antarctica is the land of ice. And I'll let you in on a secret. So at NSF, we refer to Antarctica as the ice. So my poor Arctic colleagues sometimes get a little mad when we talk about the ice, but it is ice, and there's spectacular sights. So this is outside of the US station at McMurdo, and there's an active volcano. So that's Mount Erebus, spectacularly beautiful. There's an ice tongue that comes off of Erebus that throws up amazing ice caves. So there's one of the ridges and sort of the view from the inside of one of the ice caves on that ice tongue. There's spectacular glaciers. So this is called Blood Falls. And what this actually is a glacier that overrides where there used to be ocean in warmer periods, and the salts left behind from the ocean sediments actually get transported to the front of the glacier. And when they hit the oxygen, the iron rusts. So what you're seeing there is called Blood Falls for a good reason. It does look like the glacier's bleeding, but it's actually ancient iron that's been oxidized. And of course, there's mega charismatic megafauna. I know Reed and John and a few other folks have been down to Antarctica on the Palmer Station side, and there you do get to see quite a few whales and killer whales. And of course, everybody's favorite, the penguins. So here's some emperors hopping out. We're back over to McMurdo now. There's me on one of the great days. Look how blue the sky is. That's Erebus in the background. And there's me hanging out with an emperor. And there are some sharp, pointy teeth in Antarctica. They're not quite as scary as polar bears are to me up in the Arctic, but the leopard seals are pretty formidable predators. And the ice is actually a concern for all of us humans who live on land as well. So let me actually pose ice as a problem, and let's launch the second poll. Which types of ice are we usually concerned about when it comes to Antarctica scaring those of us in the United States? So which type of Antarctic ice do you think plays a role? Sea level rise is the big thing we're worried about. All right, coming in, we got ice shelves, ice sheets, a little bit of sea ice. Moving on, a couple more people voting. All right, I think Parker, that looks pretty good. If we want to end the poll and share the results.
1 second. Let's see, and share.
Great. All right, guys. So ice shelves are the big winner. You guys might not know the difference between shelves and sheets, and I'll get to that in a second. And ice shelves do play a role, but most of the time what we're worried about with sea level rise are the ice sheets. So we will we'll delve into that. And the sea ice plays a role in terms of protecting things from waves, but really for sea level rise, the sea ice isn't going to be a big player. So let me tell you the story about why we're a little bit worried about the ice sheets. Thanks for running the polls, Parker.
No problem.
All right. So again, a reminder, we got a continent that's 98% covered by ice. And basically it's as big as the entire 48 US states. If all of that ice on top of the Antarctic continent were to melt, we would have maybe on the order of 70 meters, 70 meters of sea level rise. So sea level would in fact go up by around 200 feet or more. Woo, that's scary. Now, the good news in some ways is that the East Antarctic ice shelf, it turns out there's a mountain range, I'm going to show you that in just a second, keeps most of the ice away from where we're really worried about the melting, and that's our biggest piece. But there's a fair amount of ice on the west side of that mountain range that we are a little bit worried about melting, okay? Not so worried about the others, and Greenland's definitely a concern, but it's really Antarctica that's the big beast in the room. So we know that the ice has come and gone in the past before. So this is actually more of a geological picture, and this is going back, you know, hundreds of thousands of years out to 1 million years. And we see these are warm periods up top in red, cooler periods down below. Temperatures skyrocket and then they slowly go down, and we build up ice, and they skyrocket and we slowly go down and we build up ice. More ice, less ocean, coast is farther offshore. Less ice, more ocean, coast is onshore. So we're worried right now about losing that ice and really having incredible sea level rises. So let's talk about those ice sheets. And ice sheets are like pancakes. What? So most of the snow actually gets added sort of in the middle of these large ice sheets and then spreads out. So in the chat, let me get some suggestions for how could we sort of slow down spreading pancakes. So not ice sheets quite yet. We're going to get there, but tell me how you slow down pancakes. Add in blueberries. I like that. That's a good one. Make them more viscous. Yes, changing the structure certainly is part of it. Anybody more flour? I like that. Thicker batter. Yep, absolutely. You guys are honing in on lots of good things. You can change your pan. That's a really good one. So let me actually hop on and show you that that change of pan is in fact really important, okay? So those bumps, I'm cheating, it's actually a waffle, right? Not a pancake, but that bumpy waffle maker really slows down the spreading. And things like cooking and all the less milk, more flour, you guys are right, changing the structure is important. But we can also kind of hold things back with spatulas. So what I want to tell you guys is that there are essentially waffle makers that are acting in our favor. And this is Antarctica without the ice on top of it. Okay, this is that mountain range that I was telling you guys about. This is all of East Antarctica, and this is West Antarctica. So the good news is that there are lots of bumps that can kind of hold that ice sheet that's behaving like a pancake in place for longer than we would think. So we can slow down the melting a little bit. The other thing, those spatulas, there's actually ice shelves. I'll show you a picture in just a second that really act like spatulas holding back the pancake batter. So we also refer to those as flying buttresses. Anybody remembers Notre Dame and keeping the sides of the building in? But those ice shelves are really important spatulas holding in those ice sheets and keeping them from pouring out and essentially melting into the ocean. So here's your picture with the different types of ice that are in the mix. So the ice sheet is the land-based ice. Okay, so it's in contact with the bedrock. Ice shelves are when the ice sheet starts floating. So it was in fact land ice that's now moving out over the ocean, but it's floating. And at this point, it doesn't impact sea level rise per se, but it's really important in slowing that ice sheet down from melting. So that's the spatula that's holding things in. And that bumpy bedrock is really important to also slow down that ice sheet. So if it gets stuck, it's not going to melt into the warmer ocean. So we got some good news and we got some bad news. Okay. So we don't really know how fast, and again, the Antarctic ice sheet is the one that we're really worried about in terms of sea level rise. Here's a slightly different estimate. We think some of the ice actually won't melt, but we are looking at about 60 meters of potential essentially melt coming from Antarctica. And this was the terrifying talk that I heard. So most of our predictions are based on models, and we don't have all the physics necessarily in the models that we need. And we're starting to understand that that melting that's going to be impacted is impacted by things like melting on the surface and how much icebergs are being produced. So how much calving is going on. And I was in a talk, not by this guy, Richard Alley, who's just fabulous. Look him up on YouTube. He gives the greatest talks. He's just a great guy as well. But one of his co-authors, Rob DeCanto, put this graph up at a talk. And I was like, oh my gosh, here's essentially how fast we think Antarctica is going to melt. And we thought it was, 5,000 years or so out. That's way in the future. Well, when these guys started modeling with making icebergs, so cliff failure, nothing happens. When they started adding in hydrofracture, so wet on the top of the ice sheet, it got a little bit worse in terms of how much sea level rise we'd see. But when they put both of those components into the models, suddenly we got, oh my gosh, we are looking at potentially 10 meters, 30 feet of sea level rise within the next 1,000 years, and maybe even faster than that. So my sad glass half empty story is, if Antarctica is going to do something unexpected, it's going to be that it goes much, much faster than we ever thought based on the earlier models. So yes, Antarctica could melt much faster than we expect it to. We want to save those ice shelves. We want to hope for lots of bumps and a few other things to slow everything down so we have time to adapt. But that's kind of a scary story. So now let me tell you a slightly better news story. I know, Reed, I'm looking at the chat. You did say I was always optimistic. So I'm going to return to the optimism, but I had to throw in a little bit of realism. So now we're going up to the Arctic. And this is a place called Kivalina on the coast of Alaska. And it's kind of like, oh gosh, is the Arctic going to be doomed? I mean, look at this place. They got all kinds of gravel in. They are literally at sea level. Is this place going to go extinct? And I would argue that probably they will make adjustments because there's just this untapped pool of indigenous wisdom. And when you go up and you start working with these communities, you really see this blending of modern and ancient wisdom. And in Canada, they really have taken it to calling that in the Arctic, they're seeing with two eyes. So they're really starting to take in different perspectives and different ways of knowing. This is actually a piece out of a grist.org article that I just love. So indigenous people with their tens of thousands of years old knowledge are only 5% of the world's population. We haven't been really good to the indigenous people, but they do actually control 22% of the land, not the surface of the planet, because we got lots of ocean, but 80% of the biodiversity can be found on that 22% of the land. So we really think that if we can figure out how to move to respecting indigenous knowledge, bringing these different ways of knowing together, that we could see some of those critical lessons and solutions that we need to bring to the table for adaptation. But we have not respected indigenous knowledge. So we really have to get to a changed place. And this is a great group out of Nome, Alaska called COERIC. It's a tribal organization. And they're really working hard on knowledge sovereignty and helping to understand how we get to respect so that we can get to sharing and get to solutions. So I was very fortunate to work with some others from East Carolina for many years up in Kotzebue, which is above the Arctic Circle in Alaska. Again, Alaska, a really big place, doesn't have very many people, but has a whole lot of land, and there is a very strong indigenous component. Kotzebue is 80% Inupiaq. And it is a place where subsistence is everywhere. So this is Front Street, Main Street, as it were. There's your sled dogs hanging out. There's a lot of salmon drying. You know, it's not for everyone. That's sort of more the look of the village, but you know, they're right on the Arctic Ocean, but they are getting a whole bunch of food from the marine ecosystem, and they've been there for at least 10,000 years. So when we went up and started chatting and started getting a sharing of knowledge, this is an example of a map where we're putting down information from some of the hunters, fishers, elders that we were chatting with. And you can see that there's just amazing system-based knowledge of what's happening within the ecosystem. So Ugruk is bearded seal, and that's really an important subsistence food for the folks at Kotzebue. You can see that there's a lot of interest. Here's where we go hunting in the spring. Here's where we expect the Ugruk to be. We know that Ugruk eat clams, so we know throughout the sound where the clams are, because that's a really important food source. We think in systems, so we understand that we have to also, where do the beluga come through? Yes, we're hunting them, but they're also a key part of the ecosystem. So we've put together a fair number of maps, like I just showed you, but also maps of the knowledge. Where do we have the different systems, the understanding? If we want to understand the Ugruk, the bearded seal, well, we have to understand the different responses in different seasons. You have to understand the system. And we as Westerners coming up to Alaska for a couple months, yeah, we can bring some pretty amazing tools to help understand the system, but really 10,000 years of knowledge that's been passed down and really system perspectives gets you to a great place where you can start to put together things. So here's actually food webs. We were doing some stuff with isotopes of carbon and isotopes of nitrogen, but we were also asking the Kotzebue hunters, fishers, and other members of the community what's going on, and they were putting together food webs. So here's probably a better picture to look at. There's that bearded seal I was talking about, and everyone knows that the adult bearded seal is quite interested in eating those clams, but they're also quite interested in eating some of the shrimp species that are there. This is a Ugrachat, which is actually the baby bearded seal. We shrunk the picture down a little bit, but that has a different diet. And again, that's very much known throughout the community. So bringing together traditional ecological knowledge, scientific ecological knowledge, and really this time immemorial respect and knowledge for subsistence harvesting, including whaling, are hugely important and are likely to have some of those secrets we need to get to those climate solutions. And it obviously also addresses the equity, right? We kind of go in with our Western knowledge and maybe we haven't been listening. And there are good reasons for that, because this is a very different way of knowing. There's a lot of scientific knowledge, but there's also a lot of spirituality and ways of life and entire cultures that are going to come in for us to get to these answers. And I am seeing quite a bit of respect throughout the community. This was a huge global ocean observing conference that was just there, and there was an Indigenous people declaration that occurred as part of that conference. University of Alaska Fairbanks is running a great series on traditional ecological knowledge, and we're starting to get Indigenous folks sharing and being part of the academic community, really emphasizing that research must be conducted respectfully, and that we are not interested in helping you guys with knowledge for knowledge's sake. We want to contribute to those solutions. We are facing climate crises, maybe more so than you guys are. We are facing equity crises. So we want to help, but we want to help with research that's going to contribute to the community. Okay, so let me ask you guys for 1 second. We're nearing the end, but who do you think you could reach out to? Your North Carolinians, who has that local knowledge in North Carolina that you might be partnering with to have equity and climate solutions in where you guys are interacting in North Carolina? And if you guys want to throw a couple things in the chat, I'm curious to see where you think you might be going for local knowledge in North Carolina. And any chats? There we go. Yes, fishermen, absolutely. Aquariums, absolutely. Local watermen, yep, 100%. And I think the local Sea Grants, awesome, is very interested in getting those sorts of partnerships going, and they really have a lot of expertise in that. I think aquarium museums, I know some of you guys are not on the coast, right? So you might not be interacting directly, but there's a lot of climate change going on inland. So farmers and other sorts of hunters and trappers inland as well, absolutely there. Multi-generational, that's the difference with local knowledge too. A lot of it is not immediate, it is passed down, and it is the community that holds that knowledge, and we need to respect the communities. Okay, so again, optimism, Reed. I really do think that we're moving towards, and the Arctic can be leading the way with how do we get to solutions for these crises, and respecting local knowledge is a big part of that. Most of you guys are probably thinking about colleges. My son Patrick shared this flyer from Kenyon College with me, where I just love, it's an undergrad biology major, with really, science is about telling these stories. It's about figuring out what you didn't know, letting people know how you figured it out, and maybe most importantly, what can you do with that? Okay, and communication is key, and getting into solution space is key. But I think really one of the most important things is all hands on deck. We want everybody involved. We need the respect, we need the humanity, and just really treat people like they want to be treated, and we all are in this together. So let's get out there and do these things. So yep, glass half empty, but there is a lot of glass half full. All of these crises are both challenges and opportunities. You do need to know where your partners are dancing from. So this is sort of the last slide. This is a great series of that the Yale Climate Change Communication Group puts out every 2 years on sort of the temperature of the United States on things related to global warming. So you guys aren't going to see the individual colors, but the reds are hot, sort of, yes, we embrace this issue, and the blues are, nah, I don't think it's really a problem. So here's kind of the big picture question of who's worried about global warming in the United States, and 63% of the adult population is. So that's pretty good, right? Okay. Here's a couple other good ones. They even redder. What is that one? That's we should be teaching it in school. So good on you guys. You're doing that. You're paying attention with your extracurricular activities, and pretty much there's consensus that that's a good thing to do. There's even consensus that we should start spending money on climate change, but we don't want to spend our own money, it turns out, but we're happy to spend other people's money. So most of the United States thinks that corporations should be spending money on climate change. So we got some consensus for getting to solutions as long as it's somebody else's money. But now I'm going to get to some of the maybe less encouraging climate as a crisis stories. So this is for 2020, lots more blue on this map. And that's, is this one of the top problems? Should this be the high priority for the current president and Congress to address? And now we're getting into a lot more blue with the coasts and Alaska, interestingly, still being pretty hot colors. But this is the one that really worries me for that knowledge to action piece. Whoo, look how blue that is. And that's, do you think you're going to be impacted by global warming? And most of America thinks it's somebody else's problem. And that knowledge to action piece really sometimes requires the feeling it yourself. So that's what awaits you as you guys bravely go out, give us all hope with solving these crises. We're there with you. And I'm happy to answer some questions now. Thanks for listening.